So we're looking at 4.6, isosceles and equilateral triangles. We're going to talk about properties. Oops, didn't mean to do that. We're going to talk about properties, and we're going to talk about of isosceles triangles and properties of equilateral triangles. This is not going to be bad at all if you do what I've got right here, which is work with what you know. That's the best advice I can give you, is to work with what you know. And in this case, pay attention to the details, being mindful of the legs, base angles, vertex angles for the isosceles, and so on. Those are the kind of things that we're going to be needing to be conscious of. We already know a lot of what we're seeing here because we know what isosceles triangles are. Now, the isosceles triangle theorem says, you can see that here, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Now, we have said that if these are the two congruents, then this is the vertex angle, and then these two are base angles, so they're congruent. What we're seeing here is they're saying if the two sides are congruent, then the angles across from them or opposite of them are congruent. So let me just erase that. But that's the gist of it. So the converse, remember, that's the flip. And what it says is if two angles are congruent, then their opposite sides are congruent. So you can see these two angles here are congruent. So the sides that are opposite them are congruent. And we're going to talk about opposite sides in another chapter and make a big deal about some things with angles and sides and size of angles and length of sides and all that. But that's the idea. So the thing about doing this and its converse is we're saying if the two sides are congruent, then the angles are congruent. We're saying if the two angles are congruent, then two sides are congruent. And that's nice. So that way you know that it's isosceles and so on. So this says name two unmarked congruent angles. Okay, now it's got some marked congruent angles because they've told us here that this angle is congruent to this one. Those are marked. But this says two unmarked. And so I would just have you draw your attention to the fact that these two sides here are congruent. So the opposite angles are congruent. And that would be, let me change my pen here. That would be this one and this one because they're opposite the two sides. So you can't really call that angle C. I wouldn't suggest you do that. You could call this angle A. The reason why I would not call this angle C is because are you talking about this angle or the whole thing? And so you'd need to be more specific. But I would call it angle BCA is congruent to angle, and I would probably just go ahead and call this CAB. Let's see what the answer key has. BCA. And they did just use the one letter for angle A, which you could have. I used A as the central letter, so that's what the vertex has to be. So that would work either way. So then they asked us to mark two congruent segments, or unmarked congruent segments. So they've got these two marked, so those are not my unmarks, right? I've been told that those are congruent. But I do have that this angle is congruent to this angle. So the sides opposite those two angles are congruent. And so I would say segment CB is congruent to segment BD, DB, whichever one you want to do. And they got BCBD. Maybe we got CBBD. Same one. Same sides. Okay, like I told you, this is the easy. It's just a matter of kind of looking, paying attention to what's going on here. This, by the way, is not intended to be a 3D figure, although you could have just a little bit of a moment where you think maybe it is. It's not a 3D figure. It's just a bunch of triangles kind of sitting on top of each other and lumped together. But it says, which statement correctly names two congruent angles? And you're just going to have to take your time on problems like this and just go through the whole thing. Just going to have to do that. So I'm looking at PJM. So it's this one here. And then PMJ. So it's this one here. Do we have any reason to say that those two are congruent? And what we'd have to have is this and this congruent. Because if these two sides were congruent, these two legs, then that would mean the base angles and all that. But we do not have that. So we cannot say that. Next, we have J, starting up here, JMK, which is this whole thing. And then JKM, which is this whole thing. Do we have anything that says that those two are congruent? And across from it would be this one, which is marked. And across of this would be this one, which is marked. So I'm pretty sure that B is my answer. If I want to be thorough, I check the other two answers. And it's like I say all the time. If you're going to go to a local restaurant, you probably don't change or check your oil on the way out the door or on the way getting in the vehicle. If you're going to get in the car and drive to Florida, you might want to do that. You want to be careful. So depends on what you're doing. I understand we don't check everything. It is answer B. When I say I check everything pretty much all the time, but I understand. Which two statements correctly names two congruent segments? So I'm just continuing on here. I'm going to look at this A. So it says JP, which is this one. And I know I'm just putting one mark like the others are already marked one, but I'm doing it in blue, so you get the point. And then PL. PL. We have nothing to show us that those two are congruent. Nothing. And they don't look congruent, but looks ain't everything, but I don't see anything. Next we have PM and PJ. In order for PM and PJ to be, then we'd have to have this angle and this angle, because across from that side, that angle, across from that side, that angle. But we don't have that, so we don't have the B answer. So we'll look at the C answer. JK, which is marked, and MK, which is this bottom side down here. In order for those to be, then you'd have to have the angle opposite that, which is that one, and the angle opposite that, which is that one, and we don't have that. They'd have to be congruent. We don't have that. So I'm hoping it's D, because I'm running out of options, but this says PM and PK, and that's true, because you can see across from this one is this angle, across from this one is this angle, and those two, in fact, are marked congruent, so the answer is D. All right, so that was the isosceles. A few things we'll work through with that. It's just a matter of paying attention. And now we're here at the equilateral. Equilateral, we know, is equal sides. And this 4-3 says a triangle is equilateral if and only if it is triangular. Now, I probably have mentioned it before, but in case I haven't, if and only if is a math saying, which means it works both ways. The point is, we could say this as the hypothesis, this is the conclusion, or we could call this the hypothesis and this the conclusion. So in other words, the statement and its converse are both true. So if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. We could wrestle through the whys, but that's the way that works. 4-4 says each angle of an equilateral triangle measures 60. Well, that kind of stands to reason. If it's equilateral, up here, back up here, if it's equilateral, then all angles are equal. And so if it's equilateral, all of them are equal. That means it's got to be 60 each in order to make 180. So we probably already knew that before we saw that particular corollary. It's just what corollaries are. Things are kind of known, obvious from the things that we do know already. All right, so find the measure of angle R. The measure of angle R is here, and we want to know that angle. Well, because these these two sides are congruent. Everybody see these two sides are congruent? Then these two angles are congruent. That's what it means. Because remember, it's the sides opposite. That's how that works. We saw that in the isosceles piece earlier. Which really means then that if that's 60, then these two add up to 120. And since there's two of them, they're 60 each. Now, they may dance through that a little bit differently, but basically we get to the same conclusion. Measure of angle R was 60. Find PR, it says. The measure of segment PR. It's this segment here. Well, because we know this is 60 and this is 60, then it's equal angular. All the angles are equal. And we already said if it's equal angular, it's automatically equal lateral also. So if that one's 5 and that one's 5, then that one is 5. Measure angle T, this one. Well, because these two sides are congruent, then these two angles are congruent. Would you agree? Because those are opposite of the congruent sides. Those are base angles. This is the vertex angle up here. That's how that would have to work. Well, if that one's 60, then that one's 60. And if these two are 60 each, which is 120, then that one's 60, making the answer C. Find TS. I told you this wasn't going to be difficult. So we want to know this side here, TS. Well, let me dance my dance here. So because these two are 3.5, then these two are going to be congruent. Do you agree? Because when you have congruent sides, the opposite angles are congruent, or the angles opposite those two sides are congruent. So that one's 60. Well, if those two are 60, that one's 60. So it's equal angular, which means it's also equilateral. And if it's equilateral, these two are 3.5, then this one is 3.5. We don't know if it's inches, feet, yards, or miles, but it's 3.5 somethings. So I've blown this one up, and I suppose if I move this, they're asked us to find the value of each variable. That's what I expected it was. And you can see there are two variables here. We have the y and we have the x that we're trying to find. There's also an x here and a y here. But we're trying to find the values of x and y. Do you agree that since these two here are congruent, then we can easily write the measures of the two sides are equal? That's 6y right there. So if I bring the y over, it's a subtraction, so it's 2y. Keep looking like a 4. And if I take the 5 across, it'll be add 5, so it'll be 8. So y is 4. So I think y is 4. I could go back and I could check what happens when I put 4 in here. For y, it would be 24, it would be 27. What happens when I put 4 in here? It would be 32 minus 5, which is 27, and that's a good thing. If I want to find the x, as I said, the x's are here. And it would appear to be the measures of these two angles. And I just marked those two angles as congruent without telling you that any justification for them being congruent. So I'm going to erase that because they're not. I think they're not. But I do know that these two are congruent. How do I know? Because these two sides are congruent. And so opposite angles are congruent, which means this is the vertex angle, because these are the two legs, which means then these two here are the base angles. You follow? I mean, I haven't done any work yet. I'm just logically looking at my situation. Okay. So here's what I've got. Here's what I've got. I've got the vertex angle, which is 4x minus 8. And let me just erase this middle stuff just a little bit so that I can see what I've got. And you know I got this, which is this angle here. But this is also this angle here, because those two angles E and D are congruent. So I'm going to go back and I've got this angle here, which is this. I've got it written here. Plus 2 times the 4x minus 8. Which means all the angles are congruent, of course. It's 180. What I probably should have done is just said that 4x minus 8 is equal to 60. Once I realized that they're all congruent, then that's how that would work, how that could work. So the 4x equals 68, and x is equal to 68 divided by 4, which is 17, I believe. I could plug those back in and confirm that that's what that is. 17 and 4. And this is our last one. We are told up front that all sides are congruent, which means all angles are congruent, because equilateral is also equiangular, which means the 3x has to be equal to 60, because they're all equal, they're all 60, and so x is 20. X is 20. As far as the side goes, if this one's 2y minus 6 and this one's 8, then you can see the 2y minus 6 has to be equal to 8 because they have to be congruent, because they are congruent. And so 2y is 14, y is 7. So x is 20, y is 7, answer B.